Okay, so I had my engineering friend over the other day, and I'm trying to talk him into doing a channel, YouTube channel. Ray, so Ray, this is going out for you. Um, so Ray and I were talking about the FIU structure. Ray's a professional engineer and got a lot to do with the Department of Transportation, um, and roads and bridges. So it'd be nice to see him do some content. He's now retired, but he's retired from the Department of Transportation, not from engineering. Um, okay, so I'm trying to talk Ray into doing his channel and sharing his awesome knowledge over his 30 years. This is the smoking gun. Well, let's jump it before I jump into smoking gun. Let's back up to last FIU bridge defendant settles with 3 victims. All right, so this is going to be about Louis Berger not settling. Louis Berger is going to go to court, which is awesome. Apparently going to go to court, at this time going to court, proceeding to court, it looks like, or going that direction. The lone holdout of the $103 million settlement between victims of March 2018 FIU bridge collapse and the companies they sued for negligence Wednesday announced it had settled 3 of the 6 wrongful death lawsuits. Do you realize they sued them for negligence and they settled? So this judge must have put something on there that you're settling, but I'm not finding negligence, I'm guessing. Because finding negligence in there would be enough for them to prosecute already. If the judge already found negligence, I mean, that's weird, right? Why wouldn't a state attorney just find negligence also? Well, of course we know why. Her conflict. And money is a conflict. These people are millionaires, right? And millionaires don't really go to jail, do they? With the odd case when they kill someone. Oh, wait a minute. They did kill someone here. Oh, but they paid for the deaths, $103 million. All right, let me jump into what I think of the people that are taking the $103 million. I'm sorry, guys, if you're one of those people watching it. I'm not trying to offend you. I'm trying to trigger you. So I'm going to call you scum to trigger you. You're now going to be in possession of, I don't know what your 1/3 of your cut is, but it's going to be millions of dollars. Do you know politicians are bored off into the low thousands of dollars, even hundreds sometimes? You can lobby the politicians. You guys have millions now, and your loved one has died, and all you care about is spending the effing money on yourself now. So I argue to you that to lobby somebody, put some of that money together, you guys get together as a group, you cheap-ass bastards, put $100,000 each as a group into it. That's $800,000. You can get hire lobbyists that will get this prosecuted, that will make sure this comes at least to prosecution. But that's the judge made that deal. And you guys, I don't know, you're just cheap bastards for not doing it. Look, if you killed my loved one and I got $20 million out of the deal, hey, thanks for the $20 million as far as the losses. And I get 1/3 of that, right? But some of that money is going right back into lobbying to make sure you go to jail just for the hell of it. Make sure you don't do this to anybody else when I say the hell of it. So that's my position on the greedy bastards that took all the money, and I see nobody stepping forward screaming. Now that they got the money settled, I don't see them stepping forward saying we want prosecution. They never did. So I find all, the word I just used, only care about themselves. So I don't care if they can get one friggin' dollar, not one of them, and that's my design is to trigger them again, to make them to use some of the money, the greedy bastards, to a lobby to get prosecution. But they'll just spend it on themselves because they're happy their loved ones died. Those people that are happy their loved ones died made them money. They are ecstatic. All right. But if attorneys for the Louis Berger Group continue to prepare for a trial involving more than a dozen other plaintiffs, listen to this. But attorneys for the Louis Berger Group continue to prepare for a trial involving more than a dozen other plaintiffs. There's a dozen other plaintiffs where they will seek to show others involved in the project were liable for any damages suffering by those parties. In all, 20 plaintiffs were part of the negotiations in federal bankruptcy court that led to the $103 million settlement, right? Let's skipping around. They include MCM, the general. Oh, let's skip around for that. Louis Berger was hired by Figg to double-check the plans, but the NTSB found Berger did not do all that was required, failed to detect the flaws that led to the bridge coming apart as traffic flowed beneath it. This is their narrative of it. All right. This, remember, we're reading South Florida. You don't have to say that this is word to word. It's no quotes there. As a status hearing, so in other words, I'm going to dive into that. As a status hearing Wednesday before Miami-Dade Circuit Judge Jennifer Bailey, attorneys announced Berger settled with the estates of Rolando Fargo. Berger settled with the estates of Rolando Fargo, Oswald Gonzalez, Alberto Ares. A fourth lawsuit filed on the family of Alexa Duran. Is that girl? Yeah, that's the one the family hopes glad she's dead. That's the one I'm talking about. You know, they're glad she's dead because they made all the money, and none of them are screaming for court action as far as legal court action as prosecution. Now, I'd love to be able to retract this statement to see them do that. Is nearing settlement. So it looks like this court, it will not be a court date. That Berger is copping out or pleading out. The amounts of the individual settlements are confidential, but leading plaintiffs' attorneys. All right, the dispute was resolved to the mutual satisfaction of the parties. All right, so it's going to be settled. We won't see a court date. We won't see this. They're throwing in a towel, whatever. But let's go here. This is the smoking gun exists. The smoking gun of this. Everybody's looking for a smoking gun. The smoking gun, or a few times the smoking gun appeared, but the initial smoking gun was here. And let's come here. On March 8th, 2018, 9:48 a.m., reported by Felicia Manuel Feliciano, whatever, to Dwight Dempsey. This is interesting, right? So, Erica, she's the post-tension person, and these are the Denny Pate. This part of MCM, I believe. Pedro Cortez, part of MCM. And it says, main span, cracks inspection of truss members after formwork / scaffolding removal. So they removed the formwork, and 2 days later, the bridge was moved. March 8th. This is kind of weird because they're saying March 8th. This is 2 days before that, but Denny Pate has reported to state that it was over there for some time and nothing showed of any nature. But here it is 2 days before the move. Cracks appear, and the cracks are represented, I believe, right here as I look at some dates on this. This is that crack. This is the same crack we know at the back of the deck. This is still over there. See the steel in the background? I was going to do a separate video on this altogether. How NTSB and OSHA say that, and the report says it was supported similar to whereas it was on the piers. Well, on the piers and the staging area, as I call the impound, not to be confused with the real impound, the one where they afterwards. This looks like steel reinforced steel, like H-beams, that are supporting some bridge work, false works to hold up the base of this pier. And you can see it's here. It's staggered, but this is under number 12 at this point. And apparently under number 12, I call number 12 this part, including the blister that sticks out of it. It looks like it has a nice piece of steel right underneath of it. Nice piece is a technical term for nice piece. Coming back to a follow-up on that, February 28th. So we have March 8th, and we have February 28th. We have many days earlier, February 28th, we have, again, cracks report after shoring removal. So we have this is from Jose Morales, stating this, the BPA, on February 28th. We have, on March 8th, Manuel Feliciano also is bringing up the cracks again. The deflection of span, but the reply back, no, Manuel, I think this is, right, this is Figg's person. See, look, down here. I remember now. This is Figg's response. And it took till March 8th, 2 days before the move. The deflection of span 1 after removal of false works are within expected deflections. Well, this is supposed to be all in compression, the structure, as Linda Figg stated, and we have a video of that. You guys, anybody can ask me for that video. and where they talk to the FIU about why they should hire them. And she states the entire instructions in compression. Denny Pate's there and also expounds on that. So here's a clip from that video. Let's jump into it. Okay, right here, you come to the video called FIU Bridge Collapse. Linda Figg, Denny Pate, MCM, and others audio, their design and thoughts. The 3224, the pylons are just for frequency. That's the pylons. It supports itself before we put the cables on it. Listen, before we put the cables on it.
Those are installed by working on the already completed deck. Yes. The strength of the bridge deck system and the roof, it'll carry all the load.
The bridge deck and the roof will carry the loads, not the truss system.
Those are installed by working on the already completed deck. Yes. The strength of the bridge deck system and the roof, it'll carry all the loads. It meets all strength and serviceability criteria. The stays are really for the additional stiffness we need to be.
Talking about the stays, he called them the pylons. But the bridge deck and the canopies, what he says, the roof takes the loads, meaning in post tension, longitudinal post tension.
I have one last question that I wasn't expecting to answer. What is your towers called at each end? The pylon? Oh, at each end? Yeah, where the elevators are located. What is that thing called? The landing. The overlook.
Yes, overlook.
Okay.
Overlook.
So that column of concrete that encases the elevator,
yes.
Let's call it the overlook.
Yes.
How do you get to the roof of that overlook?
Well, yeah, we
wrote details to the roof. 30 years later, when we had to re-roof it, short of I'm sorry.
No, it's all post-tension concrete, so it's everything's in compression. So you're gonna.
It's all post-tension concrete. Everything is in compression. Everything is in compression. She states it there again. There we go again.
I'm sorry.
No, it's all post-tension concrete, so it's everything's in compression. So you're gonna maximize that durability well over 100. I mean, it's gonna be like 150 plus years. So it's all post-tension concrete, so it's everything's in compression. So you're gonna maximize that durability well over 100. I mean, it's gonna be like 150 plus years.
The bridge basically takes its position across the highway in one night.
Yes,
sir.
Yes.
We will build pieces. Bob, tell me where I'm out of turn. Piece. Well, this piece gets built. This piece is built here and swings over on the summer.
It drops in.
And drops in on the summer night. So everybody said, wow.
One night. And it supports itself before we put the cables on. It's the cables that we need to be able to handle the frequency for the pedestrian movement.
See that the frequency for the pedestrian movement, it's the cables themselves. It supports itself otherwise, she's stating.
You load the whole bridge up. We want this to be very comfortable for the user. The concrete allows us to do that. The stiffness of these stays allow us to do that. The whole frame system allows us to do that in a unique way. That's why we're integrating a truss and a cable stay structure all as one unit, which
Linda, go back to the one day movement.
One day.
All right, that takes that. Now the next section to the north. Is that a second day, a week later, a month later?
That's going to be cast in place because we are out of the fray of all of these items, and so it's much easier to take then the formwork that was used here and recycle that into this component here.
This would be a pioneering job, and it's testament to the models of what FIU is doing on the accelerated movement. So, there's just nothing there.
I'm off that point. Go back to what you said. The bridge basically takes its position across the highway in one night.
Yes,
sir.
One
we will build.
This is the first span, span 1.
Pieces. Bob, tell me where I'm out of turn. Piece. Well, this piece gets built. This piece is built here and it swings over on the summer.
It drops in.
And drops in on the summer.
They're probably looking at a model and showing them a model or drawing when he's saying this piece here. Yeah.
Right. So everybody said, wow.
Well, not-
Don't that.
And now Linda Figg will explain it also. Again, it was set up to work in one piece. It would be freestanding. Listen to her wording again.
And it supports itself before we put the cables on. It
supports itself before we put the cables on. She calls it cables, and it's not cables. They're the steel resonance, the pipes.
Cables that we need to be able to handle the frequency for the pedestrian movement. If you load the whole bridge up, we want this to be very comfortable for the user. The concrete allows us to do that. The stiffness of these stays allow us to do that.
Now, she changed it now to the stiffness of these stays. So you see where I went with that? First, sounds like cables. Now she calls them stays. So she's, I don't know, man. I don't know. She can't keep her mind straight with whether she's talking about cables or the steel pipe stays.
The whole frame system allows us to do that in a unique way. That's why we're integrating a truss and a cable stay structure all as one unit, which
Linda, go back to the one day.
Now, that the entire bridge is in compression. If it's all in compression, you can't get deflection in the span. It says talking about the span. The design is such it's got a top chord and a lower chord, or a top flange and a lower flange. If you look at it as an I-beam, and if an I-beam has a top flange and a lower flange, upper flange and lower flange, let's call it, if it deflects, well, now you got the top flange in compression, a lower flange in tension, but it's a little more complicated than that because this is concrete. So it doesn't make sense. And if you're getting that deflection, you now are deforming your uprights, your diagonals. Next 6 minutes of this video, it's a teaser video already put out, but I'm throwing it back inside this video to just keep the continuity going. In that video, it's going to talk about what I call the smoking gun, the cracks. You know, we're always looking for a smoking gun. On the FIU bridge, the smoking gun are a few details, and part of those details are mentioned in, okay, I can't remove that one yet. And the report, or reports, memos, question marks that go back and forth about the deflection after span 1 after removal of the false works. This was a question on March 8th. It was also a question on February 28th. This will be part of the video down here, and I'll go into it back and forth of what of the smoking gun of the cracks, but I'll also show how Linda Figg and the concept of their design is kind of confusing to them. Not to blow it off, but this is Linda. This is Denny Pate's Linda Figg's engineers responding. And if you look at the small print, it'll be much better in the video. He states that on March 8th, it's 2 days before the move, they do not have, through extrapolation, we know they do not have the answer back as of this date, 2 days before the move, of why these other cracks are presented. He states the deflection is just, it's expected deflection. Let's talk about that expected deflection. The deflection, I can theorize, is in the middle. Even though we have the break here and here, I think this is more like a crack or a brittle break fracture, like a cracker breaking here and here at the time of the failure, the load being, the deflection happened, the stress is resolving here and here. Watch how I'm in that video. I'm going to just hide this into the video also. So this is kind of a double video inside this video. So this would be a steel pipe. They're secured with bolts, steel bolts, secured. Nothing to elongate. No. They're a pinned connection. It doesn't slide or move. These are permanently locked in connections. Now watch when this is the member or the canopy. If this bridge has deflection, watch what happens when I deflect just a little bit in the middle here. Do you see what happens with the deflection? At this joint here, it starts pulling down on it. But it has no choice to pull down on it. Pulling down on it would create, if this just pulling down only, it would start pulling this, want to pull this over, this on this side connected here, would want to resist that. So you're going to get some failure at some point. You're going to start getting failure. Some failure, it will start happening. The bolts aren't going to be able to hold that structure from deflecting. But we have 1, 2, 3. You got to combine them all, how much an effect they would have. But she stays there for resonance, not for supports. Although she calls it a cable stay bridge, and a couple of other times cable stays. She goes back and forth. But deflection causes, see the deflection down, will cause the stress on this connection here, and including the middle connections, all the connections all the way both directions. The least amount of deflection would be just using this scale here. You can see the least amount of deflection would be down, closer. This moves a 1/2 inch. Well, did I get that right? You move a 1/2 inch here, least deflections on the outside. So you see that the stresses are still there. You just can't get it though. See how I move that down? That's deflecting down. That puts this in compression. Yeah. It's trying to get smaller. Let's do this. Just do this. I said, yeah. Okay. So that's our one that's going in tension on the bottom side, and on top is compression. I want you to look at it I want you to look at it as concrete. So the top side of the concrete is the very top of this. Oh, I can make it bigger. Okay. Let's do that. So the very top of this, if I can point down, the very top of this purple is in compression, and the very bottom side of it is in tension. It's wanting to pull apart. That's the tension side of it, wanting to break. So when you get that deflection, you're getting some compression and the tension moments on the top member and the bottom member individually. The top, doing this again, puts this in compression. Let's do a little bit more exaggeration. So it puts this part in compression, and the outer side, you can see it's clearly had a stretch. It becomes in tension. That all helps the structure fail. If this is in place, if this pulls down, now watch what happens. I had it up top. Now what happens when I pull this down? It also wants to pull these joints apart if these could stay in place. But remember, they do have some secure anchoring here at the 12. This level number 1 rather sits on a deck. So if you try to pull that down, the resistive force wouldn't be equally bending together. They all have to interact, so they're creating, part of that slide friction that would be going on there if it could move. Otherwise, it just fails. If it can't move, it just fails. If it hits an abutment, something that's non-movable, it just fails in buckling, if you will. I'm going to be happy saying buckling. If it could move out of the way, then we could say it sheared it off. It sheared it out of the plane. And that's the down here. But we have a bar in there which would resist that shearing off, pushing it out of the plane. Oh, this video is getting too long. I'm going to terminate it. This is my teaser video for the down here, but we can come back to that. Let's talk about that in a second here. The deflection of span after removal of the false work. So up here it's referred to as formwork and scaffolding. False works, same thing, okay? It's the same intent. Are within the expected deflections with no calculations supplied. And this is a professional engineer, Figg, bridge engineering. Regarding MCM's photos, we need a better description of the locations and widths of the cracks in order to provide you with our evaluations. So MCM's photos that they sent over to them, which we don't have access to at this point, exactly per this letter here. This is 2 days before the move. They still are talking about evaluating cracks. And they have not determined what they mean. In general, the cracks seem to be very small, and some of them appear to be shrinkage cracks. Okay, so some of them appear to be shrinkage cracks. And shrinkage cracks, how did he determine that? There were no testing done, etc. Shrinkage cracks are on the surface, incidentally, guys, are not transversing any member. There is no shrinkage cracks if you're transversing. Shrinkage cracks must be on the surface. If it's fully through, it's a full crack. It's a full break, and at that point, you've got your steel activating and handling the structure. Just imagine if it's cracked through, the concrete is the piece to the left and right, north and south, however you like to look at it. Those are 2 separate pieces, only being connected by post-tensioning or steel. I guess I could, if it was fiber cement, I could argue that it's also being connected by the fiber, in which case that's referred to as toughness, how long it takes to break apart, basically, layman's term. Deflection was first in this failure, explains cracking. This is what I'm telling you. Figg admits bridge had issues. No deflection was in the scheme of plans. So I'm using their words because remember in Rome you always I can adapt, guys. So if I'm in a city and the guys are saying yo what's up baby, well then I can say yo what's up baby. If I'm in professional meetings, everyone says oh good day, have a good day and good afternoon, things like that. That's the way I talk also. So you have to adjust to per your persons, including Manuel Feliciano. Everything in this form. There's two different communication formworks. Formwork, scaffolding removal. False works, all the same. Let's jump to, this is my I am Drake. So I lost some images, but let's go to this. This is another. Did you review the structure in terms of the different sequences of construction, in particular the different stages of construction, or did you just review the entire structure as one structure? My model is the structure as one structure. That's Berger's position, period. So this was not done. Berger was basically saying, hey, this works as is, but you didn't give me stages to do, so, how can he be at fault? Nevertheless, the lawyers are making a deal. Okay, that's just me talking about how can it be sliding. These are the engineers' images that we have present, and this is all of a sudden having a sliding effect. Isn't that amazing? This is supposed to be sliding, but if we look at this, this is open, and since he can explain, this engineer over here, this professional engineer, is capable of seeing, evaluating shrinkage cracks to some degree here, and these others you can't evaluate at all because he didn't do it. We have, if this is sliding, how is this section here able to slide over? Forget the post-tension, the number A bar, the lower post-tension bar is in there and you can't go through it. And also the B bar, you can't go through it without causing disruption in this member here. These cracks are open in nature. How is this sliding and able to bridge this crack and then start pushing on this side? It's open in nature. I just find it's an assault on intelligence, my intelligence for sure, or anyone's intelligence. Any engineer that states that this is sliding, all you have to do is look at the deck, and then you look for the bypass. You can see connections still there. You'd also have this gap to deal with, and you would argue that these cracks are not relating to any sliding, maybe some hinging going on, but no slide action is going on. This is not indicating of that in any capacity like these cracks. This is a twisting torque action, number 12, leaning away from us in this capacity, and that gives you the torque action there. Going to why I have this video, FIU Bridge Collapse Model Part 3-A, Sagging Deck Explained, Longitudinal Post-Tension Failure. All right, so I'm referring to this as that sagging that the engineer refers to as acceptable is, to me, means that that the post-tensioning is failing in this system. The longitudinal post-tensioning is allowing this deflection to take place. It can't deflect if the post-tension won't allow it to deflect. And its deflection is the smoking gun image, again, would be here. This is why it's still over there in the staging area. This crack appears. It means nothing to them. They can't figure out why. This is because number 12, with the post-tensioning still in it, no slide action going on, this is already, if you would get down here, you would see this is already elevated, and a torque action has already taken place in this millimeter, thousandths of an inch, let's call it, because it's under an inch, so let's just refer to it as thousandths of an inch. You could scale this with a gauge and actually see the elevation change in this concrete. So don't think, visually you try to look at it. You can literally use a scale, and you could come down here and say this is 3 thousandths, and down here you could say it's 6 thousandths of an inch. Go, wow, it's elevating, and it's elevating from here to here, and this means something. This means this torque action is taking place. And keep in mind, though, this is while it's sitting on top of the piers. It's still in its original position. That means the most support is present. minus the tie down here. There's no tie down through this hole here to help it with some rotation, but there appears to be no lift off on this steel. Nobody's took any measurements off this steel. It's probably in the thousandths of an inch again. Again, I'm breaking, don't think less of thousandths of an inch. That means I just broke down it an inch to 1,000 scale. And no movement is no movement. In other words, I can put a thousandths of an inch scale on this and there's no movement, right? Steel. So you have this center of the structure. The scaffolding is removed as reported by everyone. At this point, this appears notably so that they photograph it. Notably so that they photograph it, but they can't explain it. This is because the torsion took place in this, what they call an I-beam. And I'm saying you're looking at an I-beam torsion is all you're looking at. That explains this crack. Number 12, the torsion that took place is because it's a scale, the ratio of this thing wasn't, the computer didn't pick it up, the engineers didn't pick it up. They were counting on the computers to pick it up, obviously. So this torque took place on number 12, a rotational torque, the elevation. Again, I'm against the sliding taking place because of the imagery. The imagery after post-tensioning, it develops more what's going on, and it shows allows greater the torque action to show itself. To me, this would probably mean that blister in the back there's this design, the blister in the back was what was holding it together. The top upper bar here was holding it, that torque action, holding that rotation in more firm location. But it can only do so much because it's on an axis, right? It's only at one point, it's in the center. Think of it as nailing a stud in the center, top and bottom. You can rotate the stud, spin it around the circle, right? Center line, I said. You can spin that stud around. You add a second stud, and now you can't spin it. Second nail on each end. You can't spin it. But now in this case, there is no second stud out here to hold this in place. It's just a single nail, if you will, in the back of here. So it would allow the rotation easier. Remember, the post-tension bar A is in the deck. That would be the second stud, but it's not in the number 12. It's not in number 12. So this is what's going on. You got a bar here, and then you got a bar sticking outside the deck in that blister. And when they detensioned it, the forces could greater rotate, and it's indicated there. I'm going to terminate this video, but it looks like there will be no court case. Louis Berger, defendant, settles with 3 victims, right? Looks like there'll be no court case. Maybe they would settle because technically, right off the bat, they were negligent because they didn't have the appears or reportedly didn't have the authorization from FDOT to be doing this type of inspection. So once you prove that this inspection is out of Berger's qualifications, you then can prove negligence at that point, in my opinion. At least if I was a juror, I would say, oh yeah, it was out of the qualifications. They shouldn't have been doing it. Over here, when you come to this video, you'll see what I've made now, a new list called Debunked Cracked. It's about 17 videos. I could probably add a couple more to them. This is the smoking gun, if you're looking for it. February 28th. The trust crack members, and also no one knows why. This is the smoking gun crack here. This will be the smoking gun emails here. Right here, 2 days before the move, deflection of span 1 after remove false work, or within the respected deflections. But then the next sentence, same paragraph, they need a better description of the location and widths of the cracks in order to provide you with our evaluations. What evaluations ever done? No, this was just a rush to judgment, a rush to get it done. That transporter was there at a tune of hundreds of thousands of dollars or whatever it was to move the bridge. So they didn't want to start arguing over a fine line because holding up everything, thinking you've got something of value. Imagine me trying to hold up a structure, telling somebody, look, this means something. We shouldn't do anything. We got to figure this out first. All engineers would blow me off. They would think nothing of this crack and blow me off. They would say, oh, I don't know what it is, but, they would say something like that. I don't know what it is, but we can ignore it. Keep going. And this is apparently what what took place. I know that all cracks are saying something. They're identifying stresses in the structure, and if you can't figure out where they're from, that's the major issue there. That's your major issue.